Alright, even if the whiteboard doesn't work, I'm going to screencast the whole thing. So I'll record it and then I'll tweet it out later. So if you just want to watch it on YouTube, you can do that. What questions do you have from anything for tomorrow? Questions about the exam in general? It is written, so that's good. Anything about the exam or specific questions or topics, or what can I do to help?
I was just gonna follow your lead, so whatever you wanted to do.
Yeah, I basically just came here to listen to whatever was gonna be going on. So.
Okay. A linearization problem. Alright, Fred would like to try a linearization problem. Okay, so I'm gonna pull up a linearization problem. Can you guys make that screen big enough so that you can see what's going on here? Alright, so linearization is really finding a tangent line at a point. So let's say, for example here, we wanted to find the linearization of f of x equals the square root of 1 plus x. Alright, at x equals 0. Alright, so what we're really looking for here is L of x. That's what I want to know. To do that, I first have to take the derivative. So find f prime of x. Alright, and that is going to be 1/2 times 1 plus x raised to the negative 1/2. Alright, and the linearization is just the slope of the line, the tan line at that point. Or the linearization, excuse me, is the equation of the tangent line at that point. So I'm just going to plug in 0, f prime of 0, which is going to be 1/2 times 1 plus 0 to the negative 1, negative 1/2, which I think is just 1/2. Is that right? Okay. So now to find L of x, the linearization, L of x equals the slope 1/2 times x minus 0, whatever the point is that you're using, minus plus the y value at x equals 0. So whatever the function value is at x equals 0. The function value at x equals 0 I think is just 1. Okay, so the linearization of x so far is just 1/2 x plus 1. And that's it. So if the question is asked for the linearization of x, that's all they want. Okay. What else? There's a problem on the test that's approximating square roots using linearization. If I were you, I would just put that in the calculator and find the closest thing to it because it's multiple choice. Probably shouldn't have told you that, but that'll save you some time. The exam is 49 problems. I think I said it was going to be maybe close to 45. It unfortunately is a little bit longer than that. I think there's a lot of it that is not, you're not really supposed to use your calculator on it, but you can use your calculator on the whole thing, so that'll make things go quicker also. If you're going to use trapezoids, it's just an approximation, right? And the formula, I don't know why your book uses t, but I guess I'll use t. T equals h over 2 times y sub 0 plus 2y sub 1 plus 2y sub 2 plus dot 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 plus 2y sub n minus 1 plus y sub n. All right, and in this h is b minus a divided by n. Okay, so let's say that, for example, let's just steal one from the book here. Yeah, I guess that's fine. We wanted to estimate the integral from 1 to 2 of x squared dx. All right. And it'll tell you the number of subintervals, so when n equals 4, or we're going to break it into 4 subintervals.
Actually, wait, this is kind of useless, isn't it, since we can just use our calculator?
Well, yeah, assuming that your A, B, C, and D, your choices are, how do I say this? The trapezoidal rule will give you a value, but it'll be an estimation.
Okay.
You know what I'm saying? So, I mean, it's certainly possible that you evaluate and the only solution that's even close is the one that you got on your calculator. It's also possible that they threw an LRAM, they threw an RRAM, they threw an MRAM, and they threw in the trapezoids, in which case it becomes, you've got to be a little bit more careful, I think.
Okay, could we do it then?
Yeah, we can finish it. So, from 1 to 2, 2 subintervals. All right, well, I don't know if we really need a picture here. I'm going to take the formula away. Alright, but what we've got is x squared, and we're going from, we'll say that's 1, and that's 2. And we're going to use a bunch of trapezoids. Okay, so if I plug into my formula, t equals h over 2. Well, first of all, we need to figure out what h is. H is 2 minus 1, that's the endpoints, b minus a, divided by n, which is 4, so that's going to be 1/2. Alright, so t equals 1/2 times whatever the initial function height is. Well, 1 squared is 1. Excuse me. Plus 2 times whatever the function height is at y sub 1. Alright, well, y sub 1 is right there. Y sub 1. Alright, so are we okay? So we got y sub 1, and then 2 times whatever that height is. Well, what's the height of x squared right there? Well, it's 2 times... Well, if we're breaking up into 4 pieces, what is the x value down there? You know what I'm saying? Isn't it 5 over 4?
Oh, yeah.
Okay. So 2 times 5 over 4 squared, right? Plus 2 times, oh, I'm going to cheat, 6 over 4 squared, plus 2 times 7 over 4 squared, I'm running out of space, plus the endpoint, right, y sub 4, which is 4. Well, alright, let's just do this, 2 squared. Okay. And so, I can't get a parenthesis in, oh yeah, maybe I can. So once you kind of click away on your calculator, you should get the approximation is 2.34375, and the actual area if you used n-int was like 2.3 repeating. So actual. Okay. And it may be that the actual gets it, because trapezoids are pretty close, especially if n is large. So depending on the function, I guess. Might not be a bad idea to look at. There is some stuff from 7.1 and 7.2. We spent a lot of time on 7.2. That was the finding the area between curves. I think there's an LRAM, MRAM, RRAM question on there. You guys need to know this. You need to know that if you have like a velocity, and you should be pretty good at this, I suppose. But if you have a velocity function on the y-axis and time on the x, and you've got some curve, you should understand that the area underneath the curve from A to B is the what? Is the distance traveled, right? So the red area here, this is the distance traveled.
Is there a lot of optimization and related rate problems?
There are 4. There are 2 of each.
Okay.
Would you like to do one? I guess we can do this balloon one. It doesn't really matter. So this is actually number 11 from page 251. Alright, so a balloon is inflated with the helium at a rate of 100 cubic feet per minute. So 100 pi cubic feet per minute. Alright, and the question is, how fast is the balloon's radius increasing the instant the radius is 5? Okay, so I think that they give us change in volume with respect to time. They give us dv dt. Alright, so I need an equation that relates volume of a sphere. I think volume of a sphere, does anyone have that real quick? And I'll give you all these tomorrow. Volume is 4/3, oh no, 4/3 pi r cubed. Okay. Alright, so, and we want to know this when r is 5 feet. Okay, so this is actually, sorry, this is simpler than I thought it was, but dv dt equals, if I throw the 3 out in front, I end up with 4 pi r squared times dr dt. Alright, and what the question is asking is, it's saying, what is dr dt? Okay, when the radius is 5. So the most important thing is to set up your equation, your model, whatever that is, and then take the derivative. Don't plug in the 5 first, because then you notice that the derivative of a constant is 0, and then you're really in trouble. So let's plug in everything that we know. We know this is 100 pi equals 4 pi r squared. Well, r we want to know when it's 5, so that's 25 times dr dt. And I think that you get the rate of change of the radius is just 1. dr dt is just 1 foot per second. Okay, so like I said, the key thing there is to make sure that you set up your model, then take the derivative, not plugging things in too early.
What's the biggest topic on the exam? We should go over that.
The biggest topic on the exam is the definite and indefinite integrals.
I understand that though.
One thing I did want to do is an initial value problem using the fundamental theorem of calculus.
Yeah, do that.
Yeah.
Yeah, this would be a good one. How about, this is actually number 22 from page 327, but there is one like this on the exam. Says this, if du dx equals the square root of 2 plus cosine of x, when u equals -3, oh, and u equals -3 when x equals 0. And then the question is, solve the initial value problem using the fundamental theorem of calculus. Alright, so the first thing we do is set up a function using the fundamental theorem. So we'll say, let u equal the integral from 0 to x of the function. We'll use some dummy variable, we won't use x. Maybe, I don't know, I think we usually use t. So 2 plus cosine of t dt. Alright, and then I want to know, u is a function, and I have a point on this function. I have x equals 0 and u equals -3. So the question is, what do I kind of add on here, plus c? What do I put on at the end to make this function, to make this the actual exact function? And the easiest way to see what that plus c is,
-3.
yeah, exactly, because the function will equal -3 when we take the integral from 0 when x equals 0. All right, and we know that this integral over here has to be 0. So in order for this function to be -3, we've got to kind of subtract the -3 from the function. All right, so that when I plug in 0 for x, I get u is -3. And if that's not enough arrows to confuse you, I can draw more. All right, but generally these problems are actually pretty simple. Just take the function, put it into using the fundamental theorem, and then tack on whatever this value is here on the end.
Okay, yeah, so you just can't confuse it.
There is an average value problem on there.
What is that?
What is an average value problem? All right, well, if I want suppose I want the average value of a function, and so suppose I had, for example, I had the function f of x equals 4 minus x squared, and I want to know what is the average value of that function on the interval from 0 to 3. Okay. To find the average value, we have this nice little formula that's something like the average value of f equals 1 over b minus a times the integral from a to b of f of x dx. That might not be a bad thing to have on your note sheet. And so basically it's just a formula, right? So I can just plug everything in. So the average value of the function that we have is 1 over b minus a. Well, we're going from 0 to 3, so 1 over 3 of the integral from 0 to 3 of the function 4 minus x squared dx. Okay. And that's it. That's something that you guys can put into your calculator or whatever, and I think you'll figure out that this is actually 1. So the average value of the function from 0 to 3 is just 1.
Thank you.
Yep. So like I said, 49 questions, all multiple choice. You can use your calculator on the whole thing. I tried to point out some things that are might be handy to refresh your memory on some of the more obscure stuff, but you guys are pretty good by now at antiderivatives and integrals, and so I really think you guys will be fine tomorrow.
Okay, thank you.
Yep, all right. And we all learned a lot about Google Hangouts, I think, so